Exercise 2.6 from the Calculus SM Yusuf book, question number 11. Let f of xy equals xy square over x cube over y cube if xy is not equals to 0, 0 and f of xy is equals to 0 if xy is equals to 0, 0. Show that f is not continuous at the origin. Let's have an approach from the line y is equals to mx. I am approaching the limit from the line y is equals to mx. For that purpose, put y is equals to mx in f of xy. Then my f of xy will be equals to f of x mx. Replace your y with mx. That will be equals to, what is your function here? Whatever your function is given here, replace your y with mx. We will get here x mx whole square divided by x cube plus mx whole cube. After simplification, I will get here x cube m square divided by, here I will get x cube plus m cube x cube. Now after simplification, I will get from here m square over 1 plus m cube. Now if you apply the limit on it, limit xy approaches to 0, 0 at f of xy. This will be limit x approaches to 0 at m square over 1 plus m cube. It will be equals to m square over 1 plus m cube. As our limit is depending upon this m, so it means our limit does not exist here. So as the limit does not exist, so the function is not continuous. So we will not proceed further. Now let's move on to question number 12. Now in question number 12, we have to find out the value of a such that the given function is continuous at 0, 0. For the continuity, we know that if the limit on the function equals the direct value of the function at the given point, then our function is continuous. So for that purpose, we have to evaluate the value of the limit. For that purpose, we are going to approach our function for the limit from the line y is equals to mx. I am approaching it from line y is equals to mx. So put y is equals to mx in our function when xy is not equals to 0, 0, because we have to apply the limit. So we'll use this function. That is 3xy over under root x square plus y square. So f of xy will be equals to f of x mx. That will be equals to 3x mx divided by under root x square plus mx whole square. After simplification, we'll get here 3mx square over under root x square plus m square x square. We can take this x square common. It will remain x. X will be cancelled with this 1 of x. We will be left with 3mx over under root 1 plus m square. Now apply the limit on it. We will get here limit xy approaches to 0, 0 on the function f of xy. That will be equals to limit x approaches to 0, this value 3mx over under root 1 plus m square. That is equals to 0. And if we take the direct value of the function at 0, 0, that will be equals to a. So it will be f of 0, 0 is equals to a. Now it is given that as function is continuous, so limit xy approaches to 0, 0, f of xy will be equals to f of 0, 0. So it means 0 is equals to a. So this is our value of a from this question. In question number 13, let f of xy equals x cube plus y cube or x square plus y square if xy is not equals to 0, 0 and it is exactly equals to 0 if xy is exactly equals to 0, 0. First of all, in first part you have to examine the continuity, and in the second part you have to evaluate their partial derivatives with respect to x and with respect to y. So for the continuity, I am using here now the other method. I am not approaching it through the line y is equals to mx. I am using here now by converting it into the polar one. Let put x is equals to r cos of theta and y is equals to r sine of theta. Now if xy approaches to 0, 0, then if we put x and y 0 here, we will get r is equals to 0. Then it means that our r approaches to 0. So now evaluate the limit. Limit xy approaches to 0, 0, f of xy. This will be equals to limit r approaches to 0, and now in function, whatever your function is, this is your function. Put in place of x this value and in place of y this value, and I will get here r cube cos cube of theta plus r cube sin cube of theta divided by r square cos square of theta plus r square sin square of theta. Now if I take common r square from the denominator, this term, take this common, this term will be equals to 1. So in my denominator, I will be left only with r square. Now from here I will get limit r approaches to 0, take r cube common from the numerator. Inside I will be left with cos cube of theta plus sin cube of theta divided by, here I will be left with r square 1. Now this will be cancelled with this one. So I will be left with limit r approaches to 0, r times cos cube of theta plus sin cube of theta. Now put the limit here, I will get 0 in my answer. Now what is our direct value for the limit for the function? My f of 0, 0 is also equals to 0. Since both of them are equal, so it means the given function is continuous. The given function is continuous. Now we have to find out our partial derivatives with respect to x and with respect to y. For that purpose, we have to apply the formula for the partial derivative that you will know very well. Fx of 0, 0, that is equals to limit h approaches to 0, f of h0 minus f of 0, 0 divided by h. Now what was our function here? Our function here is f of xy is x cube plus y cube divided by x square plus y square. Now here what we have to get from here? H and 0. Replace your x with h and replace your y with 0. We will get here h cube plus 0 over h square plus 0, that will be equals to h. So just replace the value here. We'll get limit h approaches to 0, h minus, what is our f of 0, 0? F of 0, 0 is 0. 0 divided by h. So we'll get here limit h approaches to 0, 1 here, that is equals to 1. Now fy of 0, 0, that will be equals to, what is the formula for that? Limit k approaches to 0, f of 0k minus f of 0, 0 divided by k. Now in your function, put this value in place of x 0 and in place of y k. After simplifying like this, I will get here limit k approaches to 0. From this one I will get k, and this is equals to 0 over k. So from here I got limit k approaches to 0. After simplifying 1, so it will be equals to 1. So it means f of x 0, 0 and fy 0, 0 exist for this given function. Now move on to the question number 14. In question number 14, the function is x square y over x4 minus y square. If f of xy is not equals to 0, 0 and 0 for xy equals to 0, 0. We have to first prove that it is not continuous, and then we have to evaluate the partial derivatives with respect to x and with respect to y. So I am using the second approach, that is for the polar one. Let x is equals to r cos of theta and y is equals to r sine of theta. Now if xy approaches to 0, 0, then put the 0, 0 here, we will get r is equals to 0. So it means r approaches to 0. So now the limit xy approaches to 0, 0 on f of xy will be equals to limit r approaches to 0. Now put these values in this given function. I will get here r square cos square of theta r sine of theta divided by r4 cos 4 of theta plus r4 sine 4 of theta. After simplification and cancelling the common terms, I will get here limit r approaches to 0 cos square of theta sine of theta divided by r times cos 4 of theta plus sine 4 of theta. If I put 0 here in place of r, I will get here undefined term. So it means as the limit does not exist, so the given function is not continuous. As limit does not exist, so the function is not continuous at 0, 0. Now we need to find out the partial derivatives with respect to x and with respect to y. For that purpose, fx 0, 0 will be equals to limit h approaches to 0 f of h0 minus f of 0, 0 divided by h. Now we have to put this h0 in place of x and y. In place of x, h, and in place of y, 0, and get the value from here. I will get here limit h approaches to 0, 0 here. After putting these values, coordinates in this function, minus 0 divided by h, that is equals to 0. Now we need to find the partial derivative with respect to y. So fy of 0, 0 will be equals to limit k approaches to 0, f of 0k minus f of 0, 0 divided by k. Now use the same value x as 0 and y as k in this function. I will get here 0 minus 0 divided by k, that is equals to 0. So this implies that f of x 0, 0 and fy 0, 0 exist. You got some possible answer here.